Hey everybody, this is Alex Merced. Make sure to like and subscribe and leave a comment if you enjoy this video, but also make sure to follow me on LinkedIn and Twitter. But we're going to continue our story. So in the last video, we talked about what are OLTP systems. So online transactional processing systems that generally favor, when it comes to relational databases, the storing of data in rows. Okay, so we saw. But eventually what's going to happen is that generally you might want to start doing analytics. And when you move to analytics, the way you're going to want to organize that data becomes a little bit different. Okay? Because now the kind of transactions you're doing are across multiple rows. So in this case, we want to set up data in a more columnar format. So first let's set up the data, and then we'll show you sort of why this is sort of the better way to do things for analytical type workloads, and what that means. Okay, so again, we have an ID, and then we have our two records. Then we have name, and we had Alex and Tony. And we have age, and we have 38 and 35. So it's the same exact data that we have here that's organized in rows. The difference is the way it's organized. Instead of having a bunch of individual rows, each column is its own clump of data. So now let's think about how that would load in memory. If I want to ask the question, what is the average age of the entire gym membership? Okay, well, if it's row-based, guess what? I have to get this row and this row. Okay, but the data comes as a bundle. So in that case, all I really wanted was the 38 and the 35, but I also had to load up one Alexo into memory, and I also had to load up two and Tony into memory, even though I didn't need that information. I just needed the 38 and the 35. Okay? So while row-based made a lot of sense when I'm just adding a row, adding Alex to the membership or removing Alex from the membership, it doesn't make as much sense when I'm doing analytical work. Okay? But in the columnar format, now if I want to ask that question, what is the average age? All I need to do is load this column into memory. I don't have to load this or this into memory. There's separate clumps of information in the way that it is stored, which means we can grab just the pieces we need and load those into the computer's memory. Now, the benefits of this is when I don't have to load up as much information about any individual record into memory to answer a question like this, which means I could probably process the average age across many, many more members on a single computer than I would be when it's row-based, because I'm using up less memory. So it scales a lot better for when you're talking about really large data sets. Okay? So fundamentally, there's a fundamental different way we think about how we structure the data. Now, again, is everything in analytics always going to be column-based? Again, there's other types of databases like graph databases, document databases that have completely different considerations. But I would say the vast majority of data is structured. Well, actually, let me caveat that. Not the vast majority. There's a lot of unstructured data, which I'll talk about in a moment. But when it comes to structured data, the vast majority of it's going to be in tables. And so then the question is, how do you structure those tables in the computer, either as rows or as columns, as far as like the way you store them in the computer, and then the way you load them up into memory. Okay? Which will affect, again, how quickly you can do certain operations. So what happens is that you have your databases that handled our transactional business, and now we want to move into the analytical side. Okay? So let me just make this square here. Boop. Make this a little bit bigger. There we go. Okay, and basically the software we'll see here are going to be called online analytical processing systems. Okay, or OLAP. Okay, so typically what's going to happen is you're going to have sort of two platforms here. You're going to have what's called a data lake. A data lake is essentially just a big storage. It's like, think of it as like a giant memory card. Okay, so while the database was also kind of like a memory card and allowed me to save data, the database was also a way of processing the data. It was also like a software that allowed me to ask questions of the data, retrieve data, update data. Data lake is just storage. Okay, so data lake is just like a big hard drive. Okay, typically either some sort of distributed storage system. Could be like a Hadoop, could be like an object storage like an S3. But the idea is that you have a lot of data and you need to store it somewhere. Okay, so you'll take your structured data that's kind of stored in your databases and you'll move it into the data lake. Okay, so that way you have all your data stored somewhere that could be a place for analytics. And then you also have unstructured data, which comes in the form of like audio, video, emails, logs, scanner data, sensor data. Okay, all sorts of different like sort of non-table data, just like you're getting these globs of information that are not easily understandable in a structured way. And you're going to need a place to go put all that, so the data lake seems like a good place to go put all that too. Okay. And, you could do analytics on the data lake, but oftentimes it's not the easiest thing to do. It requires a lot of engineering to do it performantly. So typically what ends up happening is that you have certain things you need to do. Okay, so things like creating reports, dashboards for making business decisions, AIML. So for some of these processes, what we'll do is you'll move that data into another system called a data warehouse. Okay, so once again, we're seeing a piece of software that combines storing the data. So again, we have another memory card that stores the data, but also has all the software for, asking the data questions and updating the data and all this stuff. The only difference is that the data stored here is probably going to be stored in this more columnar format, more optimized for analytics. Okay, so the database, and again, this is very high level. Okay, there's a lot of devil in the details, but database is oftentimes better for transactional processing, and then data warehouse, essentially the database for the analytical process. So then what you would do is you'd move some of your data over to the data warehouse, and then you would create all your analytical stuff there. Okay, and ask the questions you need and generate the reports you need and the dashboards and all that fun stuff. Now, what's happened over time, okay, is that this takes too long, because oftentimes to get from these pipelines, like to move the data from here to here, which is referred to as a process as called export, transform, load. So you're taking the data out of the database, you're gonna clean it up, do some work on it, transform it, and then you're going to load it into the data lake. And then you're going to do the same thing, take that data from the data lake and ETL to the data warehouse. And it's not just two pipelines. It's not like, hey, boink, boink, A, B, B, C. Oftentimes, there might be many different, and one single pipeline is really just a single programmable or programmatic task in the process of getting data from point A to point B. There might be several different pipelines, because I might move the data to the data lake, but then I might have another job that takes that data in the data lake, transforms it into a separate copy of the data on the data lake, and then maybe I might do that 3 or 4 times. And then that last copy, I then make a copy over to the data warehouse, and then there's more jobs that then transform that even more times. So you end up having this big chain of steps that are dependent on each other. Okay, so there's an issue of, one, just writing all that code. 2, making sure that all that code runs in the right order. So that's called orchestration. And then the cost, because you're making copies of the data. So that means storage costs. You have to run computing power to run all that code, compute power. So all this got really expensive. Okay, let's just get kind of straight to the point. Okay, so basically moving the data from here to here and then from here to here got expensive. And on top of it, you ended up with multiple copies, because you now have the data stored here, here, and here. Okay, makes sense to have 2 storage, because again, the storage here is going to be more optimized for transactional processing. So, but these 2 generally, here the data warehouse is going to store it, optimized for analytics, and usually in the data lake, you'll store your structured data in a file format that's optimized for analytics called Parquet or ORC. That'll store the data in a columnar format. So theoretically, that is optimized for analytics. Problem is, like, the data lake just doesn't have the nice, SQL focused, because SQL becomes this standard way of talking to your data. So databases, you can use this language, structured query language, SQL, to talk to your data. In data warehouses, you can use SQL to talk to your data. Doing that in the data lake has traditionally been very difficult. But now we end up in this world where there's this new concept called the data lakehouse. So the idea is, wouldn't it be nice to have the feel of a data warehouse, but instead of copying your data, we just work off the data in your data lake. So the idea is that instead of having a platform that has to come with its own storage, is that you'll have data lakehouse platforms that give you that whole SQL world, okay? Or just a better analytical platform, a data lakehouse. So it's a platform that's going to allow you to do analytics, but the platform's all around making it easier to do analytics directly from your data lake. Okay, so they basically, the platform does all the logistics of how to make data lakes fast, how to make them easy, so that way, hey, I just don't need the additional copy of my data. Okay, and this is like a really new trend. Okay, but reason is because people need their data faster. Waiting for these pipelines takes too long. The cost of these pipelines take too much. So if I could just kind of stop here and just work here from the data lake, that's going to save me some time. And that's why this data lakehouse trend is becoming really popular. So generally there's dedicated data lakehouse platforms. Most data warehouses are developing features to be able to access your data lake. So that way you don't, to give them a little bit more of a data lakehouse story. So that's essentially a high level of the OLAP world. Okay, so again, the people who are responsible for moving this data from point A to point B to point C, they're referred to as the data engineers. The people who then put together these reports, these dashboards, they're the data analysts, and the people who put together the AI and ML models and train them and the LLMs, they're your data scientists. But bottom line is, if the data engineer doesn't deliver the data and deliver good data, well, then those other things can't be done, which is why this is such a lot of money goes into this particular piece of the story. So yeah, so hopefully that helps you get a better understanding of this. Again, this is very high level. If you want to learn more about this, just subscribe to the channel, because I'll be going deeper and deeper and shedding the layers of this particular story and doing more sort of whiteboarding diagrams like this. Also, we'll be doing in the future some lessons on SQL, giving you the ability, showing you how to build your own data lakehouse, so you can actually build a data lakehouse on your laptop and see how easy it is to work with data in a data lakehouse format for analytical purposes, and kind of go from there. So subscribe to the channel, like the video, subscribe. I'll see you all later. Have a great day and enjoy.